So today, we're going to tear down one of the most fascinating outages in recent memory. We're looking at how a single, almost microscopic error inside Amazon Web Services snowballed into a massive, region-wide catastrophe. It's a story about a digital giant stumbling and what that revealed about the systems we all depend on.
I mean, it's a question we almost never ask, right? We just assume these massive cloud platforms are, well, infallible. But they're not. And this story, man, it's a huge reminder of the hidden fragility in the digital world that's running pretty much everything these days.
So it all kicked off with one tiny logical error. But wow, did it trigger a chain reaction? We're talking 15 hours of chaos that spread across dozens of services and affected countless customers. And this wasn't, some server just breaking or a cable getting cut. Nope, this was something way deeper, buried in the very logic of the system.
Okay, let's go back to the beginning. We're going to start at what you might call the crime scene. We need to trace those first symptoms to really get a feel for the chaos that was erupting as one of the most important parts of the AWS network just started to fall apart.
It all kicks off with this flood of errors from DynamoDB, which is Amazon's absolutely critical database service. And then, boom, the dominoes just started toppling over one after another. All of a sudden, virtual servers, EC2 instances, they just wouldn't launch. Serverless Lambda functions went completely silent. Network load balancers started glitching out. For engineers all over the world, this was the start of a very, very long night. So you've got total chaos spreading, and the hunt is on. AWS engineers kicked off a frantic search for that single point of failure. It's like a high-stakes digital detective story, with them following a trail of digital breadcrumbs to find the real culprit.
Okay, so to really get what happened, you need to meet the two main characters in this drama. They're not people, they're automated systems. First, you have the DNS planner. Think of it as the strategist. It decides which servers should get which traffic. Then you have the DNS enactor. That's the worker bee that takes the plan and actually makes it happen, updating the system's address book.
Now, on the surface, the system had a pretty smart safety measure: 3 separate, independent enactors, for redundancy. The idea is simple. If one fails, the other 2 can pick up the slack. But, and this is the big but, there was a hidden flaw in this design. They were independent, sure, but they had no idea what the others were doing. They weren't built to check each other's work.
And this right here is where everything just completely fell apart. It's a classic software bug, a race condition. It happens when 2 things try to do a job at the same time and create a totally unexpected, and in this case, disastrous result. Think of it like this. You got 2 librarians. One is really fast, one is a bit slow. The fast one gets a new instruction, updates a card in the catalog, and throws the old one away. A moment later, the slow librarian, who's working off an old, outdated list, finally gets to that same spot. They see the card is gone and think, whoa, this whole drawer must be wrong, and they throw the entire drawer away. That's basically what happened here. The slow enactor, acting on old info, deleted the entire active address for DynamoDB.
And there it is, the smoking gun. The official report puts it so simply, but it's chilling. The address for DynamoDB in the biggest AWS region was just empty. It was wiped clean from the internet's address book for AWS. For any other service trying to find it, DynamoDB had literally vanished into thin air.
So DynamoDB is effectively invisible. And now the second act of this disaster is about to begin. That one tiny error is about to create this massive ripple effect, setting off a cascade of failures that's going to tear through the entire AWS ecosystem.
And the blast radius was just huge. See, tons of other services secretly rely on DynamoDB to function, so they all started to break. EC2, the service for your virtual servers, it starts screaming that it has insufficient capacity. Lambda, the serverless platform, just stopped running code. Even the systems that let you log in or that run call centers, they started to fail. It was a full-on system meltdown. And there's this fantastic analogy for what happened to EC2, which really makes it click. Imagine you go to a car rental company, but their main database is down. You can see hundreds of cars sitting right there in the lot. But when you go to the counter, the computer system says, sorry, 0 cars available. That is exactly what EC2 was going through. It had plenty of servers, but its brain, which relied on DynamoDB, was convinced they were all gone. Okay, so how in the world do you fix something this massive?
Well, the road to recovery was not a quick flip of a switch. It was this careful, methodical, and very long process of putting all those digital dominoes back upright, one by one. And this timeline, wow, it really shows you just how painstaking this whole recovery was. Just think about it. It took nearly 2 hours just to figure out the root cause and manually put that DNS record back. But the crisis wasn't over, not even close. The rest of the day was spent slowly, carefully, bringing all the other broken services back online, a process that took another 12 hours to fully complete.
All right, so what's the takeaway here? What can we all learn from this? Because this outage isn't just a crazy story, it offers some truly timeless lessons for anyone who builds or even just uses complex systems. And that's really the most important part of all this.
So, lesson number 1. It's a big one. Automation is amazing. It's what makes a system like AWS even possible. But this event is a stark reminder that without proper safety checks, that same automation can cause absolute catastrophic failure. Every single automated process needs to have guardrails and a clear, obvious way to roll back when things go sideways.
All right, lesson 2. This one's a little more subtle, but it is so important when you're thinking about system design. It's about the difference between redundancy and immunity.
See, AWS had redundancy. They had 3 enactors, but they didn't have immunity because all 3 of those enactors were capable of making the exact same logical mistake. True resilience isn't just about having backups. It's about designing your system so that one single type of error can't take down all of your backups at the same time.
And that brings us to our third and final lesson. And this one applies to pretty much any project, big or small.
This whole outage was never just about DynamoDB. It was about all the other services that were secretly depending on it. The failure of that one core service rippled out and took down everything else. It's a powerful lesson. A hidden connection is a hidden point of failure. You have to know how all your pieces are connected. You know, there's a quote that just perfectly wraps this whole story up. Resilience is not built in the easy times. It's built in how we handle failures. The true measure of a system's strength isn't that it never breaks, it's about how it recovers, and more importantly, what we learn from those breaks to make it stronger for next time.
And that really just leaves us with one final question to chew on. Think about it. The apps on your phone, the banking systems, the power grid, we are surrounded by these incredibly complex, interconnected systems. And after seeing how easily a giant like AWS can stumble, it's really worth asking yourself, just how resilient are the systems you rely on every single day?